Good morning to all. Today we are going to discuss about the analytic function. Suppose f of z is said to be analytic function if satisfies the following conditions. One of the condition is what? F dash z not f dash of z not exist. That means f dash of z not equal to limit z tends to z naught f of z minus f of z naught by z minus z naught. And f dash z exists for all z in the complex plane. So the function is said to be analytic means simply in our language we can say that the function is differentiable. The given function is differentiable. Differentiable means what? Already we discussed in the previous class. It satisfies the property f dash of z naught equal to limit z tends to z naught f of z minus f of z naught by z minus z naught. This condition satisfied, or if the function is differentiable, then that function is said to be the analytic function. Suppose the function is analytic at every point on the complex plane, that function is said to be entire function, or this is also called a integral function. Suppose the function is analytic everywhere in the complex plane, that is called entire function. This is also called a integral function. And analytic function is also known as a holomorphic function, also holomorphic function and regular function. These two are the other names of analytic function. Suppose the function is not differentiable at some particular point, that particular point is called singular point. If you observe, if f dash z naught does not exist, then z equal to z naught is called a singular point. If the function is not analytic at some point, that point is called singular point. For example, f of z equal to 1 by z. First, differentiating this value, f of z differentiation f dash z, 1 by z differentiation minus 1 by z square. Okay, this is exist only z not equal to 0. If z equal to 0, something by 0 is we get infinite value. So that this is exist only z not equal to 0. Okay, that means this is analytic only z not equal to 0. Okay, similarly, if you observe the other example, z square by z plus 3 by z plus 3 into z plus 4. If you substitute z equal to minus 3 and z equal to minus 4 here, then this will be tends to infinite value. So that this value analytic only z not equal to minus 3 and 4 case only. Okay. If z equal to minus 3 and z equal to 4 case, the function is said to be not analytic. So these points are called a singular points. Okay, next CR equations. CR equations are also called Cauchy-Riemann equations. So a necessary and sufficient condition for the derivative of the function exists for all values of z in the domain are dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y are continuous functions in x and continuous functions of x and y in R. So CR equations, in this case, necessary and sufficient condition. The derivative of the given function exists, it has the necessary and sufficient condition. That is, if f dash z is exist, if the derivative exists, then first condition, all the partial derivatives are continuous. Okay, next, second condition, dou u by dou x equal to dou v by dou y, dou u by dou y equal to minus dou v by dou x. Okay, these two conditions are called a necessary and sufficient condition to find the given function is analytic. So function is analytic means what? It is differentiable. Differentiable means what? Every point case we have to use the definition of the differentiable. It is complicated procedure. So it has the conditions. The two conditions are necessary and sufficient condition. If you observe the second condition, the second condition is also called a CR equations, Cauchy-Riemann equations. That means the given function is analytic or not, just check the CR equations. If the CR equations are satisfied, we can say the function is analytic. CR conditions are necessary but not sufficient. Suppose f of z equal to u plus iv is differentiable, it must satisfy the CR equations. Okay, next properties of the analytic function. Take the two functions f of z and g of z are any two analytic functions. Then f plus g, f minus g, f into g, f by g. That means addition of two functions, subtraction of two analytic functions, multiplication of two functions, ratio of two functions are all analytic function. Here the denominator term must be non-zero. Then only we can say analytic. Next, analytic function of an analytic function is again analytic. That means suppose take f is analytic. Then analytic function of an analytic function. That means g is also analytic, f is also analytic. Then the composite function is also analytic. Okay, what is the meaning? Analytic function of analytic function is analytic means composition function. F circle g or g circle f is analytic. Similarly for the entire function, an entire function of an entire function is entire. That means suppose f and g are two entire functions, their composition function f circle g or g circle f are also entire functions. Next, derivative of analytic function is itself analytic. That means what? Suppose f is analytic, then differentiating f dash is also analytic. If f is analytic, then f dash is also analytic. Next, harmonic function. A function satisfies the Laplace equation. That function is called harmonic function. Suppose here we are taking pi. Pi satisfies the Laplace equation. Dou square pi by dou x square plus dou square pi by dou y square. Okay. So Laplace equation means what? Second order derivatives equal to 0. Sum of second order derivatives with respect to x and y equal to 0. That is called Laplace equation. Any of the function satisfies this equation. That function is called harmonic. Conjugate harmonic function. Suppose take the analytic function w equal to f of z equal to u plus iv is an analytic function. U and V, both U and V satisfies the Laplace equation. That means U satisfies this equation, V also satisfies this equation. Then U comma V are called complex conjugate or conjugate harmonic functions of each other. U and V are called conjugate harmonic functions of each other. That means U is called a conjugate harmonic of V or V is called a conjugate harmonic of U. Next, we know the CR equations. If you observe dou u by dou x equal to dou v by dou y, dou u by dou y equal to minus dou v by dou x. This is in the Cartesian form. So we can represent the CR equations in polar form also. Suppose f of z equal to w, that is f of r e power I theta. Substituting z equal to r e power I theta, then u and v becomes functions of r comma theta. In this, dou u by dou r equal to 1 by r dou v by dou theta, dou v by dou r equal to 1 by r dou u by dou theta. These two are called CR equations in polar form. If the problem is involving in terms of the r comma theta, we use polar form. Okay, suppose if the problem is involving in x and y, we use the Cartesian form. According to problem, we use that one. Observe the first problem. Show that f of z equal to z cube is analytic for all z. So let us take the f of z is z cube. Substituting z equal to x plus iy whole cube. Use a plus b whole cube formula. A cube, b cube, 3a square b, 3ab square. Then separate the real and imaginary parts. X cube minus 3xy square, I into 3x square minus y cube. So real part is u, imaginary part is v. Now we have to check whether CR equations are satisfied or not. Dou u by dou x equal to x cube differentiation 3x square and x 3y square constant, x differentiation 1. Dou u by dou y. With respect to y, x a constant. First term 0, y square differentiation 2y into 3, 6y. Next, dou v by dou x. With respect to x, y constant 6xy, second term 0. With respect to y, x constant 3x square minus 3y square. Now check dou u by dou x equal to dou u by dou y, both are equal, and dou u by dou y equal to minus dou u by dou x minus difference if you compare both values. That means CR equations are satisfied. That means the given function is analytic. Let us do some other problem. F of z equal to z plus 2z bar is not analytic. in the complex plane. So take the function substituting z equal to x plus iy, 2e into z bar is x minus iy, multiplying 2x minus 2iy, x plus 2x 3x, iy minus 2iy minus iy. So equating real and imaginary parts, real part is u equal to 3x, imaginary part is v. So dou u by dou x equal to 3, dou u by dou y equal to 0. With respect to x, there is no x value in v, so 0. Dou v by dou y with respect to y minus 1. Observe, dou u by dou x is not equal to dou v by dou y. Dou u by dou y is equal to dou v by dou x. That means out of two equations, only one condition satisfied, one equation satisfied. So any one of the equation fail, then you can say the function is not analytic. CR equations are not satisfied. So next, show that the real and imaginary parts of the analytic function W equal to log 2 satisfies the CR equations when Z not equal to 0, find dW by dz. So problem is given here, we have to prove CR equations are satisfied, but CR equations are satisfied, but Z not equal to 0 case, the function is not analytic. So take the function W equal to log Z. In this case, we are taking the polar form. Why? Because we cannot separate the real and imaginary parts if you take Z equal to x plus iy. So that we are substituting r e power I theta. So x plus iy equal to log r e power I theta. Log r plus log e power I theta. Log r plus I theta. So equating the values here, x equal to square root of x square plus y square, theta equal to tan inverse y by x. Already we know the polar coordinate r values and theta values. Substitute here, then that will be x plus iy equal to log x square plus y square whole power y by 2 1 by 2 I tan inverse y by x. Equating real and imaginary parts, u is 1 by 2 log x square plus y square, v is tan inverse y by x. Now differentiating u value with respect to x and y and v value with respect to x and y. Dou u by dou x 1 by 2 log x differentiation 1 by x, like 1 by x square plus y square. Next x square plus y square differentiation 2x, 2 cancel, dou u by dou x value. Dou u by dou y value also similar manner. Dou u by dou x tan inverse x differentiation 1 by 1 plus x square into y by x differentiation with respect to x, y constant, y into minus 1 by x square, 1 by x differentiation. Similarly for the dou v by dou y value. Dou v by dou y value also tan inverse x differentiation 1 by 1 plus y square, x square into y by x differentiation 1 by x. So dou v by dou y equal to x by x square plus y square. If you compare, all the values are equal. So CR equations are satisfied. Okay. Now find the dW by dz. So in this case, W is u plus iv. So here dou u by dou x plus I into dou v by dou x. We have calculated dou u by dou x and dou u by dou y value. Substituting and simplifying, you will get 1 by z value. The function f of z is analytic everywhere except z equal to 0. If you substitute z equal to 0, we get infinite value. So z not equal to 0 case, this is possible, but z equal to 0 case, this is not possible. Find whether the function is analytic or not. Sin x sin y minus cos x cos y. Take the function. Now comparing real and imaginary parts. Real part is sin x sin y, imaginary part is cos x minus cos x cos y. Find dou u by dou x, sin becomes cos. Here dou v by dou x minus cos x, cos differentiation minus sin, minus into minus plus sin x cos y. Dou u by dou y, sin x constant, sin y differentiation cos y. Dou v by dou y minus cos x fixed, cos y differentiation minus sin, minus into minus plus. Comparing, dou u by dou x equal to dou v by dou y. Both are same. Dou u by dou y equal to minus dou v by dou x. Here the second condition failed. Only first condition satisfied. That means what? The given function is not analytic. Any one of the condition is failed, you can say the function is said to be not analytic.